Hello and welcome to this dev live session about Helidon and Verrazzano and how to build high-power apps with easy multi-cloud deployments. My name is Dmitry Aleksandrov. I'm part of the Helidon team at Oracle. And today, together with me, will be my good friend David Cabelus, Senior Principal Product Manager at Oracle, responsible for Verrazzano. Just starting with this slide to show that everything can change fast, so whenever you take your business decision, please consider checking everything once again. Yes, if you have been in our previous talks here at Oracle Dev Live, you know that we are building microservices, and we are building them in different ways with Helidon. So, but this time we will go a little bit further. As the system grows, not only one microservice, many microservices, and transactions are kind of very important in these systems. And since it's distributed transaction, it makes the situation even harder. So we have decided to show you how to do it the best way with most modern features coming with Helidon. So for that, we have chosen something which we like very much. There's good news happened earlier this year. You know that Oracle is now title sponsor for Red Bull team or Formula One team. That means that we have decided to create an example for a Formula One ticket booking system with Helidon and Verrazzano. Let us actually do it, and first of all, let us get acquainted with the technology for those of you who don't know. Once again, Project Helidon is used to create microservices in Java. I like this name very much because in Greek it means swallow, which means that it's like a small bird flying in the clouds. Like it's a very good representation of what microservice is. Small bird, very maneuverable, very fast, flying up in the clouds, just like microservices this day. It is open source under Apache 2.0 license. That means everything is available on GitHub, so you can just see the code and eventually contribute there. So PRs are accepted. Built on top of Netty, it has everything out of the box you need to run cloud natively, like health metric checks, tracing, and to make it even more faster, we fully support GraalVM native image. So the overall architecture of Helidon is like this. So we get Netty, then we have a layer of reactive services, fully reactive services, which is Helidon Reactive. And to make it portable, we have chosen to live in MicroProfile world. And we'll jump into this topic a little bit later. So Helidon SE or Helidon Reactive APIs, please have a look on the previous dev live, happened September 21, and everything is written there. So please take a look at this session if you want to actually know more about Helidon SE. For this demo, we have chosen a Helidon MP, and MP stands actually for MicroProfile. So what does that mean? That means there is a set of specification developed by community, by many vendors, for microservices written in Java. This 13 specification are actually the backbone for everything, and specification means that it's not the implementation, it's up to the vendors to create implementation for them, but specifications are there to make everything portable, so it's very easy to migrate from one server to another if you are living in frames of the specifications. And they are all set for microservices. As you probably see, there is fault tolerance because microservices is a distributed system. There's metrics, there's JOT for security, the health checks. So you can call other services using the REST client, and you can document everything with OpenAPI there. And Helidon is definitely a good choice. So if you are writing already something in terms of MicroProfile, it's very easy for you to migrate to Helidon, and it will provide you really, really cool numbers. As you see, we are Java 17 plus actually product. So that means that we fully support modularity, we fully support native image, and we fully support everything in Java world, and we are so much optimized there. That means that the numbers that you see here are really, really small. And as you probably see, that out of the box, you not only get everything related to MicroProfile, you get even some extra stuff. It's like WebSockets, for example, like transactions, persistence, cores, even, and gRPC, and one specification which is a little bit, I would say, under umbrella of a MicroProfile, but still not there fully, is GraphQL. So you also have it out of the box, and just by using Helidon, you are fully prepared to live in this cloud microservices world. But there is another specification which is very important for us, and now with the release of 2.4 of Helidon, we now fully support it, and this specification is called MicroProfile LRA, or Long Running Actions. So once again, it's under umbrella of MicroProfile, but it's still not in this in those main set of specification. But once again, it's so important because microservices is a true example of a distributed system. And to make transactions in distributed system is hard. And MicroProfile LRA actually provides you everything you need to run your transactions in distributed microservices world. So it's based on Saga pattern. It relaxes some of the famous ACID constraints of transactions, and it enables us to do transactions across actually independent microservices. For this, Helidon uses Narayana or Oracle TMM as a coordinator. We'll take a look a bit later what actually Helidon coordinator, how it operates across services. But the main idea is that Oracle TMM, it actually has to be released quite soon, as our solution, or as Oracle solution, to provide you transactions of distributed microservices in, once again, following the Saga pattern and following the MicroProfile array specifications. So if you take a look actually what our system should be, we see that we need several services. So first of all, the user should contact the Formula One booking service, and somewhere inside this booking service would call to other services where we need to book a seat. So we have a special service for a seat booking system, and we have a payment service. So for example, the user have to pay for the ticket. And this all forms kind of a business transaction. And for that, as you see on this picture, we have this LRA coordinator, or as a special dedicated service that actually takes care about all this transaction happening. So it coordinates everything, and he decides whether the call is in transaction or it's out of transactions. So once again, there are two main components involved. So they are the microservices that are used in one business request. There can be multiple of them. They just have to be annotated with LRA annotation. And there is an LRA coordinator, so it's a devoted service. It's running, well, in this combination of other services, but it's devoted service, which implicitly controls all of those transactions. So MicroProfile has created a specification which provides several annotations to actually describe your microservices, which means that whenever you have to be in LRA world, you just annotate them, your microservices and the methods in them in special ways. So for example, LRA means that this service is part of an LRA. If you say that the transaction is completed and there is a method to complete a transaction. So you just annotate it with complete. If something goes wrong, you have to roll back a transaction. You annotate the method used for that with compensate. You also have status. You also have way to forget about transactions and to, like, for example, leave the transaction if everything is okay. We will see this in the example. And this example we will make with Helidon. So once again, you can do it easily with Maven archetype. Just include it, and you will have everything I have described in this in the previous slides about what are the features of Helidon. Have everything there, so you just start your application, and it will be available. We highly encourage you to use our CLI for creating microservices because it highly optimizes everything. You can create application, build them, and develop with them. But let us actually jump into the code. So TMM, we said that we'll use TMM as a LRA coordinator. So I will just use a Docker image for that. You see, it starts very easy. So now we have a service which actually runs as an LRA coordinator. And let us jump to our example. So I have created just 3 small microservices. Here is the F1 booking system is an umbrella service, is a payment service, and a seat booking system. So I made them so easy just to describe how it actually looks. So it's a standard code and it's a portable code in terms of MicroProfile. So the F1 booking resource has only one service called make booking. And this booking accepts a seat number and a credit card number, just as a very easy REST command, a REST GET command. And what it does call a F1 booking seat service, so to book a seat. So one transaction is formed out of seat and out of payment. This can be done in parallel. And as you see, we just annotate them with a transaction that says, okay, so for making a new reservation, you just need a new service. The payment services and the booking services are also very small. They're just there to show that, for example, the make payment command, it just said that it has to be running in an LRA only environment. So this is part of the transaction. And everything, after everything is okay, we say that LRA is finished and everything is working perfectly. If everything is okay. For seat booking service, we say that it's also just a small method, which has actually 2 methods. So once again, we create booking for a seat, so it also has to be part of the LRA. But if something goes wrong, for example, the seat is failed, like for example, here we say that all the seats except 1F are available. He said that we have to compensate it. For example, if you can't book the seat, the compensate method will be called. That means that the payment should not go ahead, and all the transaction has to fail. Yes, and this is basically it. So as you see, just with few annotations like LRA, you create a set of rules for controlling your transaction. And let us try to do this. So I have actually compiled them, and just to save you time, I will run 3 microservices. So it's Java minus jar. So I have made an alias about Java minus jar. It's JJ, and 3 services are running. Let us see. See, the start is so easy, so fast, as we say. Well, currently it's experimental feature, but in the next release it'll be fully available under production. So long running actions are running, and let us actually try to book something. So we will do curl, and we will say that we want to book a seat. So it forms a transaction, And if we go to the outputs, we create, yes, the booking is successful and the payment has been made. Yes, LRA has finished. So we called 2 services and all of them are ready. If, for example, we say that this credit card is wrong and we are not able to do this, so we run it. We say that, we see an example there, and we say that we try to create a booking, but this booking has failed. And we say to the LRA coordinator, which runs actually here, that this response has to be, this transaction has to be cancelled. And that means that you don't have to continue. And as you see, just a small example, how it runs and how easy it is to create this, this distributed transaction just with few annotations. You are ready to do this. The only thing you actually have to show is that for each service, you have to create a property about where actually the coordinator is. In our case, is in this service. And just to say that what is the participant URL. I did it like this just because I'm running a local environment in Docker. Most of the time you just specify a URL, which runs somewhere in your cloud deployments. And by the way, as I say cloud deployments, let us actually deploy it in Verrazano. So you can see how all this, this project technically runs in the clouds. So several microservices, they talk to each other, and they form transactions. And now we are ready to get them to the clouds. And for this, I kindly asked David Cabelus to take over and to show us how to do this in Verrazzano.
Okay, perfect. So thank you, Dmitry. So now that we have these container images, how do we actually take them and deploy them into the cloud? Right. So we have these 4 microservices, and we have them together as, and I'm calling it here, an application model. And I'm using that term very specifically because we're actually going to use Verrazano to deploy this application system into the cloud, right? So if you're not familiar, Verrazano is an enterprise container platform. It is made up of a series of open source components. Some of these are from community-led projects. Some are from Oracle-led projects. We take them, we take the source code, scan for vulnerabilities, build from source, and then we make this available as a platform, right? It has its own life cycle, and it is truly designed to run, your traditional applications alongside your Java microservices, alongside your Polyglot microservices, and it is designed to run across Kubernetes clusters, right? And these Kubernetes clusters can be in Oracle Cloud, it can be on premises in your own cloud, it can be on other cloud platforms. It is truly a multi-cloud enterprise container platform. And so let's go back to the word model. So within Verrazano, we've adopted Open Application Model as the deployment strategy for deploying applications. So Open Application Model enables you to write microservices that are agnostic to, or they're not tied to any particular cloud platform where you're going to deploy them. And then you have your application operators who take those components and assemble them into an application configuration, right? So we're going to this is what we're going to do here today. So we're going to deploy that unit, that application system as a unit, and we're actually going to do it across clouds. In my demo setup here, I've got 2 Kubernetes clusters. These are on Oracle Cloud in our Oracle Container Engine for Kubernetes. And in Montreal, I've got an admin cluster set up. So in Verrazano, you can have 1 admin cluster and N managed clusters within a Verrazano environment. And in this environment, we're actually going to use the admin cluster to deploy into the managed cluster. And then after it's deployed, metrics and logs are pushed back to or scraped to the admin cluster, right? So we use the admin cluster as as the central point of management. And so I mentioned, this notion of components and application configurations. So with Open Application Model, for each of these microservices, we have to define what the component is. And it's a pretty simple YAML file that's required. And I'm going to show this as 4 separate files, if you will, but really I can deploy them as one file. And I'm just going to list out the individual components, right? So in this case, the first component, I have this F1 booking service. That's sort of the outermost service. And this is a Helidon workload. So we've extended Open Application Model to provide some additional automation and goodness under the covers for things like Helidon, for WebLogic workloads, for coherence workloads. But we're not, those aren't required, right? You can create just a regular container, and then we'll deploy that as a containerized workload. So important things here are the name of the service, the type of workload, and then the container information. And so we know we're going to access this container at port 7000. For the seat booking service, again, a Helidon workload. Here's where my container is, and I'm going to access that at port 7001. Payment service is very similar. And then the LRA coordinator that we're going to deploy, we're going to use Narayana here. And this one we're actually going to access at port 8080. And you can see this is just a containerized workload. So those are the components, and we will define them in Kubernetes. And then after we've defined those components in Kubernetes, we deploy this application system. Right? And this is also set up in the YAML file, and you can see I've got this F1 booking service, and then I'm going to list out the components, and then I'm going to apply traits to these components that sort of map it to the system, right? So first I've got this F1 booking service. I'm going to provide a metrics trait, which basically says when you're connecting to this container, you need to the pods, you need to use port 7000. And then I'm going to expose this one service using an ingress. So I apply an ingress trait. This is a pretty simple one, basically says, you can get to this application at this prefix once it's deployed. And then under the covers, Verrazano does the heavy lifting of setting up a gateway and a virtual service and exposes this application outside of the Istio service mesh. For the rest of the components, again, this is one file. So I've got the seat booking service. Again, how do I get to the metrics? No ingress trait for this one. Same with payment service, no ingress trait. LRA coordinator, no ingress trait. So these are not accessible outside of the service mesh. And the last thing I want to point out here is this placement. Right, so we can tell Verrazano where to deploy this application. So if you remember, I had 2 clusters in my environment. I have the admin cluster, which we actually call local within the system, and then my remote console we call managed one within the Verrazano environment. So in this case, I'm going to actually deploy it into managed one. And I want to show you, just want to tell you what Verrazano is going to do as we deploy this, and then I'm going to switch over and we're actually going to do this, right? So when you deploy your applications, you apply the components file or files, and then the application configuration file. Besides creating the namespace, Verrazano gets a token, creates a service account, uses that to create an authorization policy, creates 4 deployments, right? Because we have 4 microservices. These are Kubernetes deployments. Creates 4 Kubernetes services, and then it creates a gateway and a virtual service for the one application that we had defined we wanted to actually expose using an ingress. Then it gets a certificate, puts that certificate into a secret, creates the network policies using that secret. So within the service mesh, by default, Verrazano is set up to require mutual TLS, and we actually kind of lock down these services so that they're not just available to anyone. And then lastly, we update the Prometheus config map so that Prometheus will begin to scrape. And in this multi-cloud, multi-cluster scenario, we actually have Prometheus running in all of the managed clusters as well. And at the admin cluster layer, so we scrape locally, and then at the admin cluster layer, we scrape those remote clusters as well. So pretty cool stuff. And we also have FluentD deployed as a daemon set in each of these clusters, and we capture the logs from all of these, all of the components that get deployed. So let's switch over to the browser, and I'll show you. I'm in Oracle Cloud here. I've got a cluster. My admin cluster is in Montreal. If we switch over and look at Toronto, you can see I've got my managed cluster in Toronto. And I'm going to use Cloud Shell. I've already got Cloud Shell set up. And I've got these files set up ready for me to go. Right, I've got my components file and my application file. So if we say, let me switch over and copy my command so I don't make a typo. Here's the first command is we're going to set up these 4 components, right? So it's one file, but there were 4 components defined in it. Same components we've been talking about all day. And then we're going to apply the application configuration, right? So this is going to create that application setup. And now this is when under the covers, so when we created these components, we created Kubernetes custom resources. And then now those custom resources are sort of waiting for something to happen. And then once this application configuration is set up, the operators within Verrazzano say, okay, this is what I need to do. Let's tell this managed cluster it needs to do all these things for us. And then the managed cluster does all that work. So let's take a look here. And you can see this is the Verrazzano console. You can see it lists out my managed clusters. But if I come back to my applications, let's refresh this. So it'll hit the back end again and say, okay, what do we have running here? This may be an appending. Nope, this is running. So this is great. So now let's go back to here, and I want to actually give this application some traffic. And this is I'm going to use the same curl commands, just kind of used the same way we would use them in the cloud here. So I'm trying to book the seat 6F using a bad credit card. I'm going to do it again a couple of times here, maybe one more time just for good measure. Okay, so that's up and running. So now let's go over and take a look at OpenSearch. Okay, so if we go here, I can look at let's filter this by this namespace, and then you can see we've got some, in the last 15 minutes, we've got a couple of things going on here. If we look for the word canceled, because remember the LRA coordinator is going to cancel these, right? So you can see we're capturing logs already. And if we go to Kiali, we should be able to see the way this application is set up. It's kind of cool. Shows us this. Yep, you can see. So we're from the browser, we're hitting the F1 booking service, which talks to everything else, right? First, it then has to talk to the LRA coordinator. You can see these green lines are the intercommunication, and oops, we'll go back to the last 5 minutes because as it's not really working anymore, it stops showing all the different connections. But pretty cool. Kiali can show you what's going on here. Okay. So let me switch back to slides and wrap up here. And I just want to remind you, right? We started from scratch today, creating a microservice system that uses transactions, and we used Helidon libraries for this to work. And then we deployed into a multi-cloud environment using Verrazzano. If you're looking for more information, lots of more information available. Verrazzano.io. Follow us on Twitter. GitHub is there. Similar for Helidon. We've got the Helidon project, helidon.io, GitHub. So that's it. Thank you for your attention. I very much appreciate it. And of course, download Java 18 now. Thanks very much.